Hello, everyone. Thank you for joining today's webinar. I'm Lucy Hodes, Senior Vice President of Media and Communications for CCA. I'll be joining via audio today, and I will be your moderator. I hope everybody's doing well. Today's webinar is Revolutionizing 5G Transport with the world's first radio-aware disaggregated cell site gateway, and it's sponsored by IP Infusion and Ceragon. And we have two speakers today. First is Gil Gabay, Vice President of Strategy and Business Development for Ceragon. He's been in the industry for more than 25 years and plays a key role in driving the strategic direction and partnerships for Ceragon. He's held a variety of leadership roles, including in R&D, product management, business development, and marketing. Also joining us is Shaji Nathan, Chief Product Officer of IP Infusion, who is responsible for IP Infusion's product portfolio. Shaji has extensive experience as a product management leader with a track record of bringing disruptive and innovative networking products to market, focused on carriers and enterprises for startup and industry-leading technology companies. For those of you in the audience, if you have any questions throughout the presentation, you can submit them at any time, and we will get to questions at the end. Also, we are recording the webinar, and it will be available on CCA's website after it's over. Now, Gil, I will turn it over to you.
Okay, thank you, Lucy, and thank you for hosting this session. So, hi, everyone. I think that the topic at hand is an important one, and I would say very relevant in terms of getting ready for next generation networks. And so over the next 15 minutes or so, I will share with you our latest thinking and trends and solutions around disaggregated cell site routing and its impact on 5G networks. I would say from a broad and general industry perspective, of course, with our implementation of it, but we'll discuss some common challenges and possible solutions when thinking of upgrading existing transport networks to meet requirements of the networks of tomorrow and sometimes even today. Of course, if you have a Ceragon specific question, then feel free to ask it, and we'll leave some time at the end to answer. And after my session, I will hand it over to Shaji, who will then expand specifically on NOS, on the network operating system, IPI's network operating system, that is really part of our routing solution. So before we dive in, I would just like to, for those of you who don't know, just a word or two about Ceragon. So Ceragon is a leader in the wireless transport space. We've been around for many years, one of the most veteran companies in the space. We have roughly 1,000+ employees, 3 regional R&D centers, and up till now, we've deployed well over 1 million boxes over the years to customers that are mobile operators, ISPs, and verticals. And of course, we're a publicly traded company, so don't take my word for it. So let's talk a little bit of 5G, which is really the catalyst for what we're about to talk about today. And 5G brings with it some exciting new services and an ever-increasing number of devices that are connected to the network. And so coupled with these new services and the ever-growing number of devices connected, there's also a strong push and desire for new network architectures, such as Open RAN, for example. And if that weren't challenging enough, then all of this has to happen now in an accelerated pace, an ever accelerated pace. And so this transition is going to be unlike any other transition that we've experienced in the previous generations. And some of the challenges are, of course, to provide more capacity, right? We need to bring in more capacity. Video is becoming more and more prevalent. We need to be able to reduce latency when we're defining the next generation networks. Then there's network slicing, right? Different types of services, different types of devices. And of course, network slicing brings with it a host of management challenges that have to be overcome. And also, of course, we want to get closer to the end user, and that means deploying more and more sites. So more capacity, more complex, more sites brings with it a lot of challenges. And so when we specifically look at what's going on in terms of cell-site routers, then traditional cell-site routers have some limitations. So let's zoom in on those. First and foremost, there is vendor lock-in, right? So routing is dominated by a very small set of large companies. And so customers and operators have very little leverage when it comes to dealing with those vendors. And really you're locked in as a carrier into a very small set of possible vendors. As a derivative of that, there is high cost. In a situation where there is vendor lock-in, there is high cost obviously associated with that. And that also in part depends on the granularity of the solutions that are being offered by existing cell-site vendors. And of course, this becomes a very large challenge when you talk about deploying more and more sites. The third point talks about the separation or the fact that current routers weren't built with a wireless transport scenario in mind, and it's not, really a huge fault historically. But when we look at the kinds of architectures and the kinds of transport networks, wireless is still going to be dominant or a very large portion of those, and so without being able to be designed and adapt to that kind of situation is a drawback, and we'll see later on how we intend to address that challenge. And the last 2 points regarding limited flexibility and slow pace of innovation, again, those are also somewhat a derivative of the vendor lock-in. Try to get something on the roadmap of a very small set of large vendors. It's going to be very difficult for you. And the pace of innovation is just simply very slow. And so you need to wait for the next and the next after next roadmap version in order to see some innovation. And so these have been limitations that have been around for a very long time. And the body that is now trying to overcome that situation is TIP, and TIP stands for Telecom Infra Project, and Telecom Infra Project is an organization that is that was erected by service providers and vendors. This is actually their slide, and you can see that there are many operators and also many vendors jumping into Telecom Infra Project. And really, the vision of Telecom, of TIP, is to promote openness, to promote standardization, to provide the ability to mix and match components. Ultimately, at the end of the day, to increase the pace of innovation and to reduce costs. So this is what TIP is all about. And when we look historically, then what's happening now with TIP is actually fairly similar to what we saw in the IT world or in the data center world, where you had the hyperscale vendors. They were smaller back then, but Amazon and the Googles and the Microsofts and those cloud vendors were really faced with a situation where the routing part was a huge challenge and obstacle in moving forward for them. And the situation that they faced was fairly similar to what's going on in telecom networks, right? There was vendor lock-in, a very slow pace of innovation, and costs were extremely high. And so it was extremely difficult to maneuver in this type of a situation. And so what happened was that world moved into an open standards type of a situation, which is what TIP is promoting currently. And so in terms of how TIP defines cell-site gateways, they actually call it DCSG, and DCSG stands for Disaggregated Cell-Site Gateway, and really it's made up of three layers. The bottom layer is the hardware layer, and there are, I would say, certain criteria and parameters that you have to comply with as a vendor in order to be considered a TIP compliant hardware for DCSG. The same goes for the network operating system, which Shaji will elaborate on. It's also subject to a set of criteria in order to be labeled a DCSG by TIP. And actually, these layers interoperate with each other. And so the whole idea is to be able to mix and match. And at the top, you have value added on apps, and we have our own flavor of that, which we'll talk in a second. And so these three components make up a what is called DCSG, a disaggregated cell site gateway. And by the way, in terms of momentum, more and more cell site routers are becoming disaggregated. So by analyst estimates, it's around 10% currently. So 10% of currently deployed cell site routers are disaggregated, and that portion with its momentum is growing and will reach around a quarter of the overall cell site gateways deployment worldwide. So this is becoming a very significant part, and there is momentum going in that direction. So in terms of openness, Ceragon has really embraced openness within our portfolio, and for quite a while now, we've introduced a concept that is called disaggregated wireless transport, which consists of three parts. So there's the radios, the all outdoor radios, whether that is an E-band radio or a microwave radio. Then there's the networking software, the NOS, and the networking hardware. And so you have the ability to mix and match those components. And when you look currently at wireless transport, it's really, or most deployments in wireless transport are really monolithic type of deployment, closed deployments, where one vendor is providing both the outdoor unit and the indoor unit, sometimes with layer 3 or with a monolithic router. And this approach allows you to mix and match the different, and of course, it allows you to apply that solution to many scenarios. So whether it be backhaul or front haul, different capacities, different networking hardware, and the capacities associated with that, and so on. So we have embraced that in the larger sense of openness. But when you dive into the IP50FX, which is our disaggregated cell site gateway, then at the outset, the design goals were to address some of the challenges that we just talked about. So one is faster innovation, and that is, of course, because of the separation of software and hardware. The second one is reduced cost, and part of that is because we are offering several flavors of our IP50FX, which we have just launched. And we also offer a flat pricing model. So there are no hidden costs and no surprises. We've built it so that it's optimal for 5G services in terms of the capacity needed, in terms of traffic rerouting, and we'll see that when we get to our radio aware app. Of course, our IP50FX is TIP compliant, and it offers also a flexible and simple solution in terms of the different capacities that you get in terms of managing your cell site routing and the associated radios connected to it. So radio aware open networking, RAON, is a concept that you might not be familiar with, so I will expand on that a little bit. So it's the app that sits on top of the software, on top of the network operating system, which sits on top of the hardware. And really, it addresses a number of challenges that we've talked about. And the four things that make up RAON or radio aware are the ability to provide a single IP address for easier configuration and monitoring of an entire radio cluster, right? So that addresses some of the challenges that we talked about when there's many new sites that you need to deploy and many radios. And so if you can do that in an efficient manner, that's going to save costs and allow you to do that quicker. The second part of RAON is centralized management for all connected radios. So again, this is a solution that was designed and taking into consideration and mind a wireless transport scenario. So it is a cell site router with a radio aware app that is connected to several all outdoor radios, and these can be centrally managed in terms of fault management and so on from a central management system. Again, this applies to many of the challenges that we talked about earlier, one of them being simplification. The third point talks about the efficient rerouting. And so there is, and I would say, intelligence inside the cell site routing as part of radio aware. It's actually implemented at all levels, both at the app level and at the network operating system level and inside the hardware. And it has the ability to efficiently reroute for optimal use of radio resources. So imagine you have a number of radios connected to a cell site router, and those radios then relay messages regarding their current capacity and what's going on with them to the network operating system beneath it. And so traffic rerouting decisions can be taken in order to make it more efficient. And lastly, there's load balancing with layer 1 link bonding. That's another feature of RAON. Again, a feature that is implemented in all levels of the disaggregated cell site router and brings with it efficiency. So going back to the 3-layer model of TIP, we are addressing those different layers. So we bring to the table the radio aware networking and the hardware. And of course, IPI Infusion is providing the network operating system. Those layers have, of course, been integrated and tested, and they offer a holistic solution for a DCSG. So with that, I will turn it over to Shaji.
Thank you, Gil. To the first slide, please. So a brief overview about how we are going to go about the presentation. A brief overview about IP Infusion and what we do, and the OCNOS platform and our disaggregation solution. Finally, following it up with a case study of actual deployments. So over to the next slide, please, Gil. So IPI has been providing network solutions basically first for OEMs, control plane solutions, and in the open source you might be familiar with our solution, which is Zebra, which is now forked off as FRR at this point in time. And independent analysts have rated us highly in the disaggregation space. Basically, we have a strong track record of delivering network solutions over a period of 20 years. Go to the next slide, please. So these are all the deployments that we have with our vertical solution, which is OCNOS, which is a Open Compute Network Operating System. And as you can see, we have a wide variety of customers, basically large and small carriers, and in multiple spaces, all the way from edge aggregation to wireless transport to packet optical transport to DC. Over to the next slide, please. So let's talk about the operating system here, the Open Compute Network OS. It's a modern, modular, scalable, flexible, extensible, and future-ready operating system. What do I mean by that? It starts off with a choice of hardware. You can pretty much take COT silicon, or you can take FPGA, or you can take a programmable pipeline or a fixed pipeline COT silicon, or basically a plain CPU or a GPU, and with a software forwarder. We basically have created a hardware abstraction layer, which basically abstracts out all the switching constructs from the underlying data plane. And we made it with a control plane, which basically gives you a highly modular way to add features and functionality. It starts off with a very rich set of layer 2 and layer 3 IP routing and switching protocols. And as and when new standards-based protocols evolve, we keep on adding to that. Because primarily we, at the very heart, we are a R&D company that does research in networking. So essentially, anything that is IEEE, IETF, ITU, OIF based specifications, as and when they come in, we are able to add those features and functionality. Then on top of that, we have added a new layer where basically our solution partners can basically extend it. Our customers can write to our APIs, extending the base capability of the hardware. And to manage all of this, we have a model-driven network management plane, which basically gives you the CLI, netconf, OpenConfig based solution. It's not a stovepipe-like implementation, which means that you have a common data model off of which you basically generate all the northbound APIs. So we make it very easy and seamless to integrate with an existing network. On to the next slide, please. So to manage all of this and to ease the system integration pains basically a network operator might have with their existing network, we also provide a management framework and a network orchestration platform. For customers who don't have a SDN-based solution, we provide this. But if you already have a network management paradigm, this solution basically sits in a tiered hierarchy. And the northbound APIs are returned to open specifications. So essentially, our aim is to basically be productive on day one by providing you with a network integration solution. And it provides you all the capabilities for streaming telemetry, event correlation, the traditional FCAPs, plus integration with third-party systems through a service integration bus, which allows you to take the network telemetry and put it into big data systems. So if you have an AI/ML-based topology, you can absolutely use this integration infrastructure. On to the next slide, please. So now to the topic of the day. So how do we come together, right? We basically take open hardware built on a open silicon, and on top of that, we put OCNOS. And in OCNOS, we basically have a container which actually allows Ceragon to innovate on the radio side. So what you end up getting is basically a radio-aware flow control. Essentially, what that means is the radio side now is basically able to actually convey what it's seeing from a radio's environment, essentially using standardized protocol, Y1731 protocol. So the bandwidth notification basically comes in, And based on that, we can take action at the network operating side, basically programming that network silicon so that you can set up the queuing and also the link bonding feature. So the link bonding feature is to provide load balancing between radio channels. Essentially, basically based on the PNM, the Ethernet bandwidth notification message and the CSF, we basically can configure this. So essentially what you get here is a virtual IDU on top of a DCSG, which has all the traditional capabilities of a backhaul router. So essentially, you basically get a centralized management for both the radio and the packet side, and also gives you a plethora of interworking capabilities by way of networking protocols. So it can fit into any existing topology. At the same time, you can basically manage your radio network as well. On to the next slide, please. So basically, the software platform essentially provides you with a solution maturity because we've been in continuous development, been deployed over by 300 OEMs and increasingly by carriers in the OCNOS format, and network simplification because we provide open specification by way of both control plane as well as management plane, which allows you to do automation on a very wide scale. And innovation agility. So essentially, it is open and programmable, customizable, which means you can leverage advances in network silicon, advances in optics, radio. Basically, you can put together a best of breed solution that is completely microwave radio aware in this particular case. And it also allows you the ability to create large scale topologies with multi-domain network automation across the radio network, across the packet side, the packet optical side. So we combine that with assured support, which gives you a carrier class support that is 24/7 support for both the hardware and software issues. So that comes to the de-risking the disaggregation. You'll be wondering, how would I actually incorporate it into my network? So here we stress on investment protection. Our idea here is to basically come in and solve a particular problem that you might have with this open solution and add scale and capacity and then take you to that next level, that seamless migration. So you don't have to do a rip and replace. And it's fully validated, hardened, and tested across we submit this operating system as well as the system for bake-off tests. So we validate against reference architectures that are out there from bodies like TIP. Go to the next slide, please. So to recap, IPA provides a solution, OCNOS, which basically straddles the boundary from all the way from access, aggregation, optical transport, and right up to the data center. And to top it off, we provide you with the network automation on scale across these multiple domains with a single platform over a choice of network silicon that can scale all the way from 60 gig to terabit scale with timing and synchronization that you need for a modern day 5G network. On to the next slide, please. So here's a case study of a practical deployment using OCNOS. So in this case, it's a mixed 4G, 5G backhaul network. The network operator in this case is APTG in Taiwan. Basically, what they wanted to do was their existing solution. Basically, they wanted to first create a unified MPLS domain and essentially wanted to take it to the next level by bringing in elements of segment routing to flatten the control plane and make it much more scalable. So on day one, coming up with a seamless MPLS solution, and then carrying it over to segment routing to flatten the control plane by decoupling state information, and essentially, scaling that network so that it's 5G ready. And the timing and synchronization, basically with grandmaster timing coming from the DCSG gateway itself to lower the overall total solution cost. And this will provide 90% of Taiwan would be covered by the end of 2022 with this network. And here we replaced an incumbent solution, and essentially we competed directly with existing OEM vendors who basically were in the bake-off test with us, and we got selected, and this network is now operational. On to the next slide, please. I'll give you another example here, and this is a network in Brazil. This is Sky, it's a 3 million subscriber network. And what we did here was to basically take their existing network, which was based on carrier Ethernet, and actually scale them to get to a level where they can actually now do transport services, mixed mode transport services with the IP MPLS integration. Essentially, a single solution that comprises of provider edge and backhaul use cases. And again, here we replaced an incumbent and essentially competed with OEM vendors. And through a bake-off test, we were selected, and this network is now operational over 2 years. It is 11 sites and 45 node network is now operational completely. On to the next slide, please. So to recap, we built OCNOS, which is Open Compute Network Operating System, built on open standards, IETF, ITU, IEEE, MEF compliant, and it addresses the end-to-end use cases, same operating system for access, PE, provider edge, cell site routing, OTN, or DC. And it's a industry-leading control plane. It has been deployed by OEMs and ODMs alike. And overall, basically with the choice of silicon and hardware, we provide you with a lower total cost of ownership. By making sure that you don't do a rip and replace, we provide you with an interworking solution. And essentially take you to that next level of networking by providing you with the ability to get to that advanced network services. So it's future ready as well. Thank you, and I will now turn it over to Lucy for Q&A.
Great, thank you very much. Reminder to the audience to please submit questions if you have any. We have had some come in during the presentation, so we'll go ahead and get started. So our first question is, what kind of savings can I expect from a cell site router as opposed to a monolithic one? Gil, I think this one's for you.
Yeah, thank you, Lucy. So I think that needs to be separated into essentially 3 different things. So there is I would say that the competitive part of it, right? So if you have a disaggregated solution that allows for more vendors, more competition, and increased competition by nature will lead to decreased costs. So that's one, I would say, competitive aspect of it. At the software layer, it has to do with the licensing model, for example, right, which is fairly straightforward, and you get all features, all ports open, no hidden costs, no surprises. And at the hardware level, what we've seen many times is that traditional solutions don't scale down very well. And so sometimes you're stuck with a box that has too much capacity for your use case. And so it's about being able to offer several granular boxes that also scale down well. And going back to the disaggregation theme, the expectation is that since there is a separation of software and hardware, these paths will continue on separately and make improvements both in terms of innovation and functionality and benefits, and also of cost.
Great, thank you. Our next question. Can disaggregated products meet 5G key transfer performance requirements in terms of aggregated capacity, latency, high density of 10 GE plus interfaces? Shaji, would you like to take this one?
Sure. Yes, I would say it's an emphatic yes, because we have solutions that actually scales from all the way from 60 to now right up to 12.6 terabits. So as the network silicon is becoming more and more capable, you'll find that it meets all the requirements for 5G, right? Slicing network synchronization, for instance, 1588, time-sensitive networking, for instance. All of these are baked into the hardware right now. And we are able to exploit that as and when a new network silicon comes in, we are able to exploit that. And proof points are basically, I gave you 2 examples of where a network operator is actually scaling capacity on an existing network and preparing it up for 5G. And in some cases, already transitioned over, some of the cell sites have been converted over to 5G. So the answer is yes.
Great, thank you. Our next question, Gil, this one's for you. What is the support model in a disaggregated scenario?
Okay, I'll give my view, and maybe Shaji will expand on that a little bit. So on one hand, in a disaggregated type of a scenario where you have different layers, then there's more vendors or more parts of the solution to deal with, right? So that's could be somewhat of a drawback. But on the other hand, those different layers are standards-based, TIP compliant, and they are interoperable. Certainly in our joint solution, and they've been tested together. And so at the end of the day, I think it's fairly straightforward to support disaggregated cell site routers together with IPI and RAON. These solutions come pre-installed, are activated and configured at the sites. And we provide full support both on the software and the hardware level. So, Shaji, would you like to expand on that?
Absolutely. We work very closely with the hardware manufacturer, basically baking in the diagnostics of the hardware platform, and with software vendors as well, whose solutions basically come in. So if a call comes in, let's look at the support model. Today, traditionally, when a call comes in, the first order of business is basically figuring out whether it's a hardware or a software issue, and then route the call. We do exactly the same thing an OEM does here. So we provide you that OEM level experience by basically making sure that the operating system has those diagnostics capabilities built in. And no matter who actually does that level 1 or level 2 support, it's very easy to discern what the problem or the issue is, and then it gets rerouted internally. It's all transparent to the end customer. So the way of doing business for the end customer doesn't change, but you get exactly the same experience. So we also provide package solutions where we put that whole thing together, validated solutions that we sell as a bundle as well. And there we support the complete layer 1 through layer 3 support. It depends on we're pretty flexible with the support model, so we can cater to any kind of business models that might exist.
Great, thank you. Our next question, would you please elaborate on the technical implementation of traffic rerouting in RAON? Shaji, would you be able to take this one?
Yes. So essentially what happens here is basically, we get a bandwidth notification message. And once we get that bandwidth notification message, as I referred to in the diagram before, basically the RAON application is sitting there, right? So we lift that packet to the control plane CPU and essentially pass it over to RAON. And RAON makes the determination on what parameters to set. And and we basically get an instruction back, and we program the underlying quality of service on the hardware on the packet side, and on the RAON side, the RAON takes care of on the radio side, the RAON takes care of that. It's a high-level explanation given the time, but we can get into greater details. We'll take it offline as well.
Great, thank you. We're coming towards the end of our webinar time here. Gil, Shaji, do you all have any final thoughts before we close out today?
No, not from my side. Thank you.
Yeah, nothing from my side as well, but thank you for the opportunity, and thanks everybody.
Great. Well, thank you both for today's presentation. Thank you, IP Infusion and RAON, for sponsoring today. And that concludes our webinar, and we hope that everyone has a great rest of the day. Thanks very much for joining.